Assalamu alaikum, my dear students. Here we have another binomial probability distribution. Let's read the question. In a certain college, 33% of the physics majors belong to ethnic minorities. If 10 students are selected at random from the physics major, what is the probability that no more than 6 belong to an ethnic minority? So it looks like in this binomial distribution, the success here is really belonging to an ethnic minority. And looks like the probability of success will be the same as the percentage. Remember, I said many times probability is the same as percentage. So it looks like P here is going to be 0.33. And of course, the fail here is not belonging to an ethnic minority, and its probability is Q, which is going to be 0.67. So the question now is, how many are selected? How many times this success fail is repeated in the number of stages? N. 10 students are selected, that is N. Is this independent? Yes, it is. Why is it independent? Because the number of students that's 10 selected, we don't know this 10 selected from how many. We didn't select 10 from 100 or from 200. We selected this from unknown large population of students. So that way, we are assuming that this large population, if we select 1 or 2, 3, or even 10, that's not going to affect the probability of the coming selections. So the probability is fixed. It's going to be always 33%. It's going to be always 0.33. P is the same in every stage. So that's why this is independent. If we're selecting the 10 from 20 or from 30, then it will not be independent. And then it will not be a binomial distribution. Now the question says, what's the probability that no more than 6 belong to an ethnic minority? That means I want the probability of more than 6. That's 6 successes, maximum 6 successes, no more than 6. So I want to find the probability that x smaller than or equal to 6. That means the probability of 0 plus the probability of 1 plus the probability blah 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 until you reach the probability of 6. Well, that might seem too long for you. In this case, you can just calculate the complementary event, or equal to 1 minus the probability of the others, the 7, the 8, the 9, and the 10. So we can just calculate 4 probability instead of calculating 7 probabilities. Well, we still have to calculate each one because these numbers are not in the table. The P is not in the table. So in this case, I have to calculate each one separately. P of 7, x equal to 7, is, remember, NCX, that was what the rules say, NCX, so that would be 10C7. Okay? So suppose you don't have a calculator. Let's continue the rule. NCX, p to the power of x, which means 0.33 to the power of x, which is 7, and then q, which is 0.67 to the power of n minus x, which would be 10 minus 7, that would be 3. Okay? Plus 10 C8 0.33 to the power of 8 0.67 to the power of 2. Similarly, plus 10 C9 0.33 to the power of 9. Same thing to the power of 1. 10 C10 to the power of 10 here, a power of 0 here. Okay, so this would be the probability of 8 equal this, the probability of 9 equal this, the probability of 10 equal this. At the end, we're going to add them one by one. So the answer will be the addition of all of these. Okay, let's see how we can. Okay, let's continue the solution of this problem. Now, If you have a scientific calculator, you can easily calculate 10C7, which is equal to 120. But if you don't have a scientific calculator, one thing you can do is you can use the rule of the combinations. So how does the combinations get calculated? The rule for the combination is factorial n divided by factorial n minus r factorial r. So let's use this rule with the calculator that you have in Windows. So here n is 10, so that's 10 factorial divided by factorial 7 divided by also, because the result is going to be a numerator and still going to divide by another denominator, which is 3 factorial. So that would be equal to 120. Okay, the same thing for every other combinations. Now we take this 120, you should multiply it by 0.33, okay, to the power of 7. So you take this 120 multiplied by 0.33 power, and the power here will be only applied to the 0.33. See, he didn't do the multiplication yet, he's just waiting for the power first. Power 7. Okay, and then when I multiply, now the power has been applied and the multiplication, so also it's multiplied by 0.67 to the power of 3. Power 3. Now this will be equal to the first value, the 0.01538. Okay, so that would be the first value. Now we can add plus again the factorial of 10 divided by the factorial of 8 divided by the factorial of 2. Now we can multiply the result by 0.33 to the power of 8, 0.33 to the power of 8, and also 0.67 to the power of 2, and then we add, and so on. We continue with the rest of the problem. 10C9, which will be 10 factorial divided by 9 factorial divided by 1 factorial, and then we multiply this by 0.33 to the power of 9, and we multiply this by 0.67 to the power of 1, which is 0.67, and you add plus 10C10. Everyone remember, hopefully, that 10C10 is the same as 10C0, which is the same as 1. So it's just we're having a 1 here. So this one will be multiplied by 0.33 to the power of 10, and then anything about 0 again is going to be 1. So we're going to make equal now to get the final answer. The final answer is 0.01854, but remember this should be subtracted from 1, so I'll say minus 1, and the answer here actually is going to be negative, but I'm going to use negative. I'm going to 0.9814, 0.98147. That's the answer then. Well, then this will be the answer.